Hello everyone, welcome to MK Academic Solutions. So in this video I am going to explain you ionic equilibrium. Okay. So in the last videos I have explained you about the chemical equilibrium, what are the applications of chemical equilibrium, what is the Le Chatelier principle, how to calculate the equilibrium concentrations, everything I have explained you in the last videos, and this is the continuation of that lesson. This is ionic equilibrium. So what is the ionic equilibrium? If equilibrium exists in between the ions, that is called what? Ionic equilibrium. Okay, means simply equilibrium involves in case of ions, means that is called ionic equilibrium. Okay, so to know what are these ionic equilibriums and everything, first of all we need to discuss about the type of compounds. Okay, type of compounds and nature of compounds. So Anthony Lavoisier classified the compounds into three different types like acids, bases and salts. Okay, so here we are having different theories, so which explains the acidic nature and basic nature of the substances. Okay, now let us see one by one theory. The first one is so first of all acids, bases and salt. Okay, so first we know what is acid. Generally in your lower classes you might have studied about what is an acid, okay, and what is a base and what is a salt. So the word acid, the word acid, what is an acid? The word acid is derived from acidus. Acidus means sour in taste. What is the meaning of acidus? Sour in taste. Sour in taste. Like lemon, orange, all citrus fruits and apple. So all the raw apples contains what? Sour taste. Means the substance which are sour in taste, they contain what? Acids. Okay. Next, base. What is a base? The substances which are bitter in taste. Substances which are bitter in taste. Bitter in taste, they are called bases. Okay, and some bases which dissolve in the water are also called alkali. So alkali base dissolve in water, dissolve in H2O. We know bases. And salt, sometimes bases we know that OH minus ion produces. OH minus ion produces. Like that also you have studied in your lower classes. And acids, H plus ions producers. And we can recognize the acids and bases by using the different type of indicators. Next, what is a salt? So salt, the substance which is formed by the neutralization reaction. Okay, acid plus base, acid plus base is gives rise to salt plus water, means the substance which is formed by the neutralization reactions are called salts. Means salt is neither acid nor base, it is a neutral substance. Likewise chemists are classified. Now let us see different theories which explains the acidic nature and basic nature of the substances. Okay, let us see the first theory. Okay, what is the first theory? We are having Arrhenius theory. So Arrhenius theory, Arrhenius classified the substances into three types, and like acids and bases and also salts. So here how he classified, on what basis he classified as acid and base, and what is a acid and what is a base according to the Arrhenius. Let us see. First of all, Arrhenius acid. Okay, so this Arrhenius acid. What is an Arrhenius acid? Okay, Arrhenius acid means the substance which produces H plus ions in the water, in the water, so is called acid, it's called acid. Okay, so what is an acid? The substance which produces H plus ions in water, means which produces proton. H plus ion is also called what? Proton. Why H plus ion is also called proton? Means we already know hydrogen atomic number is 1 and it contain 1 proton and 1 electron. There will be no neutrons in the hydrogen, and when you remove this electron, it form H plus. H plus contain only 1 proton. That's why here H plus is also called what? Proton. Means the substance which produces 1 proton when they dissolve in the water. Like that also we can define. Okay, so the substance which produces H plus ions in the water are called acids. Okay, say for example HCl is there. HCl, when you dissolve in the water, it produces H plus plus Cl minus. So it is producing hydrogen ions, so it is an acid. And H2SO4, sulfuric acid, so it produces 2H plus plus SO4 minus 2, 2H plus plus, okay, so H2SO4, H2SO4, it is a sulfuric acid, produces 2H plus in presence of water. So these are what? Acids. Next, Arrhenius base. What is the Arrhenius base? Arrhenius base means, children, the substance which produces OH minus ions. Okay, the substance which produces, the substance which produces OH minus ions in water. The substance which produces OH minus ions in the water, means when they dissolve in the water, they produce what? OH minus ions. Such type of substances are called Arrhenius bases. For example, here we are going to take sodium hydroxide. When you dissolve in the water sodium hydroxide, it produces Na plus plus OH minus, Na plus and OH minus ions. And you take calcium hydroxide, CaOH taken twice, this gives rise to H2O, Ca plus 2 plus 2OH minus ion. Means the substances which produce OH minus ions are called what? Bases. Next, neutralization. What is Arrhenius neutralization? Means, children, acid plus base gives rise to salt plus water. This you have studied in your lower classes also. So means what you have learned in the lower classes, that is Arrhenius theory. Okay, salt plus water. See, for example, I am going to take HCl as acid and NaOH is the base, sodium hydroxide. It gives rise to NaCl plus H2O, NaCl plus H2O. So this is what neutralization according to the Arrhenius. Okay, so these are all things you know in your lower classes only. Okay, means you have studied about the Arrhenius theory in your lower classes only. Means, so once again, so what is Arrhenius acid? The substance which produces H plus ions in the water, acid. Arrhenius base, the substance which produces OH minus ions in the water. And neutralization. What is a neutralization here? This acid plus base is gives rise to salt plus water, that is the neutralization. Okay, so this is about what? Arrhenius theory. Next, we will see what are the limitations of Arrhenius concept. Means what are the drawbacks of Arrhenius concept. So the first drawback is it recognizes the dissociation of acid, okay, of acid and base in aqueous solution only. Means compulsory water is required here. Okay. So, to recognize acidic nature or basic nature, what we require? Compulsory water is required. For example, I am going to take HCl in presence of C6H6 benzene. So, in C6H6 this is not at all going to give as, this is not at all going to give H plus Cl minus, means this reaction is not at all going to occur, means now HCl is not an acid when you take the solvent C6H6, or else you can take the carbon tetrachloride also. In that case HCl is not at all acid. And also even base, you take the sodium hydroxide in presence of C6H6 benzene, it is not at all going to give Na plus and OH minus. So, this also not possible, means it is also not a base in presence of C6H6. Only in presence of water only HCl produces H plus ions and sodium hydroxide produces OH minus ions. If you change the solvent other than the water you are going to take, means they are not at all going to behave like a acid or bases. Okay. Next, it could not explain the acidic behavior of CO2 and SO2. So, here we already know non-metallic oxides are acidic in nature. You know this, you have studied in your 10th class. So, non-metallic oxides dissolve, non-metallic oxide act as acid. So, these are all also having what? Acidic nature, but Arrhenius theory is failed to explain the acidic nature of these type of substances, and later it was modified as the substance which produces, and when they dissolve in the water, if they produce H plus ions, they are called acids, like that he covered. So, means initially he failed to explain what is the, why these are acidic in nature. And next, it could not explain the basic nature of ammonia and sodium oxide. Metallic oxides act as bases. These things also we know. Okay. Non-metallic oxides act as acidic in nature, whereas metallic oxides, some metallic oxides act as basic in nature. These things are not explained by the Arrhenius theory. So, these are the drawbacks. So, what are the first drawback here? It recognizes the acidic and basic nature in the aqueous solution only, means water compulsory required. It does not explain the acidic nature of non-metallic oxides, basic nature of metallic oxides. So, these are the drawbacks in Arrhenius theory. Next, we will see Bronsted-Lowry theory. So, this is also called proton theory of acids and bases. Okay. First, let us come here. What is the Bronsted acid? So, here Bronsted and Lowry, two different scientists first of all. So, they individually put forward this theory, and that is why it is known as Bronsted-Lowry theory. First, Bronsted-Lowry acid. What is the Bronsted-Lowry acid? The substance which can donate H plus ions. Means proton donor. So, here proton donor means H plus donor. Proton donor is called acid. And proton acceptor is base. Okay. What is a Bronsted base? Proton acceptor is base. Proton acceptor is what? Base. Okay. So, what is a Bronsted acid? Means the substance which can donate the proton, they are called Bronsted acids. And what is a Bronsted base? The substance which can accept the proton are called Bronsted bases. Okay. Right. Now, let us see neutralization. What is the Bronsted-Lowry neutralization means transfer of proton from acid to base is the neutralization. For example, here we are going to take one reaction HCl plus H2O. HCl plus H2O here I am going to take, and it gives us H3O plus Cl minus, H3O plus Cl minus. See here, HCl now losing one proton means it is transferring one proton, and here when you see water H2O and it becomes as H3O plus means it is accepting one proton. So now here HCl act as acid. HCl act as acid. Why HCl act as acid means, children, here HCl donating one proton. So we know already proton donor is what? What is a proton donor? Proton donor is acid, and here H2O accepting one proton. So proton acceptor is a base. So now here H2O act as base, HCl act as what? Acid. HCl act as acid and water act as a base. So this is the Bronsted acid and Bronsted base. Next, conjugate acid and base. Conjugate acid and base. So before that, let us see one more example here only, and you take the NH3 plus H2O gives rise to NH4 plus OH minus, NH4 plus OH minus. So now in this one, NH3 to NH4 plus, so means NH3 accepted one proton, H2O donated one proton. So now here H2O act as acid and NH3 act as base. So now here this is also called what? Neutralization according to Bronsted-Lowry theory. Transfer of proton from acid to base is called what? Neutralization. Okay. Next you will see conjugate acid and base. What is a conjugate acid base pair? Conjugate acid base pair. The conjugate acid base pair. So the acid and base are having only one proton difference are called what? Conjugate acid base pair. So see here, the acid and base, the acid and base are having only one proton difference, only one proton difference, only one proton difference is called conjugate acid base pair. Conjugate acid base pair. Okay. So now let us see how to understand this conjugate acid base pair. See for example how HCl, let us consider HCl plus H2O. Okay, like this I am going to take here, and we know here it produces as H3O plus Cl minus. Okay. So now you consider the backward reaction also. So now here we know HCl is acid, here H2O is base, Come that side. Okay. So here H2O is a base, and you see in the backward direction now. If you see in the backward direction, here in backward direction H3O plus is losing electron. So now in H3O plus losing one electron means it act as acid, and Cl minus in backward direction, if you see, Cl minus is gaining one proton. So see here H2O is losing one proton, Cl minus is gaining one proton, means it act as proton acceptor, it act as proton donor. Okay. So now it act as what? Base. It act as base. So now you consider this is the acid, means this is a base. Okay. So now HCl and Cl minus you compare, both are having one proton difference. Both are having what? One proton difference. Means HCl is having one H plus, Cl minus is not having H plus. Means only this hydrogen only is difference here to here. So if you consider this as an acid in forward direction, now it is the base in backward direction. So now these are having only one proton difference. Such type of substances are called conjugate acid base pair. Okay. Such type of substances are called what here? Conjugate acid base pair. So now here if HCl is acid means it is a conjugate. It is a conjugate base. Next here H2O is a base. H2 is acting as a base, and here H3O plus acting as what? Acid. Okay. Now you consider it completely is base. Now it is an acid. So now which acid it is? Conjugate. Conjugate acid. Now in this, what are the conjugate acid base pairs here? See here in this one HCl comma Cl minus are conjugate acid base pairs. Next H2O comma H2O comma H3O plus. H3O plus, H2O comma H3O plus, both are act as what? Conjugate acid base pair. This is a conjugate acid base pair. This is also conjugate acid base pair. Okay. So right, this is about the conjugate acid base pair. Next, let us see here only H3PO4. H3PO4, so it gives rise to H2PO4 minus, means here it is losing one H plus ion, means it can transfer one proton. So now it is a acid, and it is a base. Okay. In backward direction if you see, means it act as what? Base. Next H2PO4 is gives rise to H2PO4 minus HPO4 minus 2, HPO4 minus 2. Okay. See here H2PO4, now it act as what? Acid. It act as what? Acid. Why? Here H2PO4 losing one proton, and it act as what? Base in backward direction. In backward direction, so it act as a base. It act as a base. Next, same HPO4 minus 2. In forward direction it is losing H plus, in backward direction it is gaining H plus. Okay. So PO4 minus 3. So now in this H3PO4 can act as only acid. H3PO4 can act as only acid, and here H3PO4 and H2PO4 are conjugate acid base pairs. Next you come here in this second one, H2PO4 minus acting as acid. it can act as base, means H2PO4 can act as both acid and base, means it can accept the one proton or it can give the one proton. When it accept one proton, act as base. When it give one proton, it act as acid, means it act as both conjugate acid and base, right. And next, in the same manner, HPO4 minus 2 also, HPO4 minus 2, in this one it act as base, and the same HPO4 minus 2, in this one it act as acid. Okay, means HPO4 minus 2 also can act as both acid and base, and PO4 minus 3, it can act as only base. Okay, so which means H3PO4 can act as only acid, PO4 minus 3 can act as only base. So this is the important question, this type of, and sometimes they may ask which can act as both acid and base. Okay, or what is the conjugate acid of particular substance, what is the conjugate base of this particular substance, like that also they can ask questions. See, for example, what is the conjugate acid of H2PO4 minus 2, H2PO4 minus 2, H2PO4 minus 2. Now, so now we know they are asking us about acid, conjugate acid, means acid and base should have only one proton difference. So here H3PO4 here H3PO4, so now it act as what, acid, now it act as base. So now they are asking about what, conjugate acid, means what is the conjugate acid of H2PO4 minus 2, H2PO4 minus, so not minus 2, it is a minus 1. Okay, minus 1. So now here our H2PO4 act as what, base. So if it is base, means acid must have one proton extra. One proton extra means H3PO4 we are going to write. Okay, so this thing also you keep in mind. So now what is the conjugate acid of this H3PO4? So conjugate acid have one proton extra, one proton extra, conjugate base have one proton less, one proton less. Okay, conjugate acid have one proton extra, conjugate acid base have one proton less, conjugate acid have one proton extra, conjugate base have one proton less. So for the same question, if I ask what is the conjugate base of H2PO4 minus, see, conjugate base of H2PO4 minus 1. Okay, conjugate base of H2PO4 minus 1 means now our H2PO4 act as acid, H2PO4 minus 1 it act as acid, they are asking base. So base must have one proton less, base must have what, one proton less, simply HPO4 minus 2. Here we are removing one H plus, means charge also we should increase. So like this. So simply what you remember, conjugate acid have one proton extra, conjugate base have one proton less. So the same manner H2SO4 also you take, H2SO4. Okay, H2SO4, HSO4 minus and HSO4 minus SO4 minus 2, like that you consider. So now here you take this one SO4 minus 2. What is conjugate acid? What is conjugate acid? Conjugate acid. What is conjugate acid means? Simply we can say conjugate acid must have one proton extra, means simply we are adding one HPO4 minus 1. This is the conjugate acid. So same question if they ask like that, SO4 minus 2, what is conjugate base? What is the conjugate? What is the conjugate base? See, what is the conjugate base here for this? So conjugate base must have one proton less. Conjugate base must have one proton less. Here there is no protons only here to lose, isn't or not? There is no protons to lose, means it does not have conjugate base. No conjugate base. No conjugate base. Okay. No conjugate base. So it does not have any conjugate base, means why? Because it cannot lose proton. And in the same manner H2SO4, what is conjugate acid? What is conjugate base? What is conjugate base? Conjugate. What is conjugate base? So what is conjugate base here? So now it is acid. Conjugate base must have one proton less, means simply the answer will give HPO4 minus 1. This is the answer for that question. So the same question if they ask, what is conjugate acid? What is conjugate acid? Conjugate acid. See, here we know this H2SO4 not accept one proton, isn't or not? It cannot accept one more proton extra, means no conjugate acid. No conjugate acid. So here H2SO4 is having only conjugate base but no conjugate acid. SO4 minus 2 is only having conjugate acid but there is no conjugate base for this. So these are the important type of questions. So frequently this type of questions they will ask in the JEE mains. Okay. Next you see some important features of Bronsted-Lowry theory. So here Bronsted-Lowry theory explains the protonicity or basicity or protonicity of acid. What is the basicity or protonicity of acid means, children? Here number of H plus ions donated by the number of H plus ions. So protonicity means number of H plus ions, number of H plus ions donated, number of H plus ions donated by acid, number of H plus ions donated by acid is called what? Basicity or protonicity of acid. For example, here HCl is there. HCl can donate only one H plus ion and Cl minus. So its basicity or protonicity is 1. Next H2SO4 is there. H2SO4 it can donate 2 H plus ions plus SO4 minus 2. So its basicity is 2. Means basicity or protonicity we can find out. In the same manner you take H3PO4 phosphoric acid. H3PO4 if you take it produces 3 H plus ions plus PO4 minus 3. PO4 minus 3. In the same manner H3PO3 it can donate only 2 H plus ions plus HPO3 minus 2 and H3PO2 can donate only 1 H plus ion plus H2 PO2 minus. So this is the basicity or protonicity of an acid, means we can find out the basicity or protonicity of an acid. Next are acidity of acidity or hydroxicity of base. Okay. Okay, what is the acidity or hydroxicity means? Here number of OH minus ions, number of OH minus ions produced by base, number of OH minus ions produced by base is called acidity or hydroxicity of base. See for example, sodium hydroxide NaOH. NaOH gives us Na plus OH minus, means it produces only one OH minus ion. So means its acidity or hydroxicity is 1. Next calcium hydroxide you take, calcium hydroxide will give calcium plus 2 plus 2 OH minus ions, calcium hydroxide. So what is its acidity or hydroxicity? That is 2. Next aluminum hydroxide will give aluminum plus 3 plus 3 OH minus ions. Okay, this is the acidity or hydroxicity of bases. Next let us see strength of Bronsted and Lowry acids and bases. So here we can compare the strength of, means we can compare the strength of different type of acids and bases. So which is the strong acid, which is the strong base, like that we can compare. Okay. So here strength of Bronsted acid and strength of Bronsted Lowry acids and bases. So here equinormal solutions of acids and bases we are going to take equinormal means the same normality. Equinormal is nothing but having same normality. Equinormal equinormal acids and bases we will take and we compare their strength and we compare their strength. So here strength means how many H plus ions they are going to be produced. Number of H plus ions produces means how much extent they are going to produce the H plus ions. That is nothing but what? Strength of acids. And how much OH minus ions they are going to produce, that is the strength of bases. Okay. See here we can take the different type of solvents to compare the strength of acids and bases. For example, if we take water H2O and to compare the strength of acids like HClO4, H2SO4, HNO3, HBr, etc. If you take like this, so in the water all they are having the same strength. If you take water, all they are having what? Same strength. So here why they are having the same strength in case of water means children here. So here water can equally dissociate these all substances. So water what it can do, it can equally dissociate all these substances, means they are all they are having the same strength in acid, in water. All these acids are having what? All these acids have same strength. All these acids have same strength in H2O. So here This is the specialty of H2O. Here water can dissociate all these substances in equal manner. Why? Because water is having high dielectric constant. Water is having what? So due to high dielectric constant of water, high dielectric constant of water. So here what is the dielectric constant means? Dielectric constant is a property which can divide the compound into ions. So ability of dividing compound into ions, ability of dividing compound into ions, compound into ions. So that is known as what? Dielectric constant. So due to this dielectric constant, high dielectric constant, all these are having what? Same strength in case of water. That's why we cannot take the water to compare their strength. And here water is known as what? Water is known as leveling solvent. Okay, so this leveling effect. So that is, so previously what I have explained you here, this is what? Leveling effect. This is only called what? Leveling effect. Leveling effect. So here water act as what? Leveling solvent. Water act as what? Leveling solvent. So leveling solvent means this acid, what the water is doing here? Water is completely dissociating these acids into equally. So means it is making equal strength of different type of acids. That is known as nothing but, that is known as what? Leveling effect. And here H2O act as, H2O is also known as leveling solvent. Leveling solvent. It is known as what? Leveling solvent, right? Okay. So next, so now then how we can find out this, how we can find out the strength of acids and bases means, so we can use the weak acid like acetic acid and weak base like ammonia to measure the strength of different type of acids and bases, to measure the strength of acids and bases, to measure the strength of acid and base. So when you see the strength of acids here, HClO4 is greater than HBr is greater than H2SO4, HCl, next to HNO3. This is the order of different type of strength of different type of acids. Okay. So in this way, by using the glacial acetic acid or ammonia, we can find the strength of acids and bases. Means when you use the glacial acetic acid or acetic acid, these molecules or these acids are going to dissociate in different percentage. So here HClO4 dissociate more percentage, means it is a strong acid. HBr somewhat less, H2SO4 still somewhat less, HCl is somewhat less, and HNO3 still somewhat less. So here more dissociation, it is the less dissociation. So in this way we are going to find the strength of these acids. Okay. Next, so advantages of Bronsted-Lowry theory. So this explains the acidic and basic nature, acidic and basic nature. This explains the acidic and basic nature of both aqueous and non-aqueous, both aqueous and non-aqueous means we can take water and also other than water also we can take, other than water. Aqueous means water, non-aqueous means other than water solvents also we can take, and we can explain the acidic and basic nature of the substances, and it explains the behavior of NH3. So we know NH3 is the base, it can accept proton. Calcium oxide act as base, it can also accept the protons, and CO2, SO2 etc. these are also act as what? Acids. CO2 and SO2 these are also what? Act as acids. Next, this theory more generally encompassing, more generally, this theory more generally okay, this theory encompassing large number of, this theory is more generally, okay, okay, it encompassing the large number of, this theory more generally encompassing the large number of acids and bases, means most of the acids and bases we can classify under the Bronsted-Lowry theory. Okay. Next, so these are the advantages. What are the advantages? Advantages. This theory explains acidic and basic nature both aqueous and non-aqueous, not like Arrhenius theory. Arrhenius theory compulsory require water, but Bronsted theory does not only water, if you take another solvents also it is possible to explain. Next, it explains the behavior of NH3, calcium oxide act as bases, and CO2, SO2 act as acid, like that also it can explain. Next, this theory more general encompassing the large number of acids and bases. Okay. These are the advantages. Now come to the drawbacks. What are the drawbacks of Bronsted-Lowry theory? What are the drawbacks? Okay. What are the drawbacks of Bronsted-Lowry theory? The first one is proton donor and proton acceptor occur only in presence of other substance. If there is no other substance, for example, simply I am going to take HCl. Here not at all, I am not adding any other substance. It is not at all going to donate any H plus. Now, in presence of other substance only, it can act as acid. In presence of other substance only, it can act as what? Acid. And it does not explain the behavior of electron deficient molecules like AlCl3 and BF3. AlCl3, BF3, this nature is not explained by this theory. So this here AlCl3, BF3 are also act as what? Acids. So these are also act as acids. Okay. This is not explained by the Bronsted-Lowry theory. Okay. So what are the two major drawbacks here? Proton donor and proton acceptor occur only in presence of other substance. Means HCl only we are going to take, no other substance we are going to take. Means HCl is not an acid. Means nobody is there to accept its proton. And next, when you take the NaOH, only NaOH I am going to take. Only, for example, only NH3 I am going to take. Only NH3 I am going to take. Okay. So only NH3 I am going to take, means it is not act as base. So nobody are there to give proton to it. Okay. Likewise, means this I think you understood this point, and it does not explain the acidic nature of these electron deficient molecules. See here, what is electron deficient molecules means having less than 8 electrons in the valence cell. They are known as what? Electron deficient molecules. For example, here you see BF3, boron trifluoride. If you take, boron is having only 6 electrons. Only 6 electrons. So it contains 3 electrons in the valence cell, and it is getting the extra 3 electrons from the bonding. So totally it is having what? How many electrons? Only 6 electrons it is having after bond formation also. Okay. So it is an electron deficient molecule. Like aluminum chloride also, it is an electron deficient molecules. So these are also act as what? These are also act as acids. But this Bronsted-Lowry theory is not explained about the acidic nature of this type of substances. Okay. Next, Lewis theory. So what is the Lewis theory of acids and bases? So what is the Lewis acid? Lewis acid here, what is the Lewis acid? Lone pair acceptor is a Lewis acid. So or simply electron pair, not lone pair, electron pair acceptor. Electron pair. Electron pair acceptor. Okay. Electron pair acceptor is Lewis acid. So here there are different type of Lewis acids are there. All cations like Cl minus, chloronium ion, Br plus, Cl plus, Br plus bromonium ion, and next Cu plus 2, Al plus 3. Next you take the Fe plus 2, etc. So these are all act as what? Lewis acids. All cations can act as what? Lewis acids, but except like H3O plus and NH4 plus, PH3 plus. So these are not act as Lewis acids. Okay. So why? Because here H3O plus only, how it is formed? H2O plus H plus, here this is formed by coordinate covalent bond. Okay. So now here it won't accept the, means it won't accept the electron pairs. Sorry, electron pair. Okay, electron pair. So cations, generally cations are having what? Acidic character. Next, compounds whose central atom has an incomplete octet. Compounds whose central atom is having incomplete octet. For example, you take the BF3, AlCl3, next BeCl2, etc. These are having incomplete octet. See, for example, you take the BeCl2. Beryllium belongs to secondary group elements. It is having only 2 electrons in the valence cell, and here chlorine making one bond, and it is giving 1 electron. So here beryllium is having only 4 electrons, not 8 electrons. So now such type of compounds are called electron deficient molecules. These electron deficient molecules can act as what? Lewis acids. Okay. Next, compound whose central atom has available d orbitals may expand its octet. For example, you take the SiCl4. So SiCl4, if you see, means silicon belongs to 4th A. So 4 valence electrons it is having. It can make bond with the chlorine, 4 chlorines here, 4 chlorines likewise. So now it is having what? Total octet electronic configuration. Even though it is having octet electronic configuration, it can expand it octet. Why? Because here silicon is having some empty orbitals, empty d orbitals in its valence cell. So see, silicon atomic number 14. Okay. So next, its electronic configuration 1s2, 2s2, 2p6, 3s2 and 3p2, 3s2, 3p2. So this is the electronic configuration of silicon. And here third cell, we know we are having 3d also. Third cell we are having what? 3d. So this due to available d orbitals, it can expand its octet, so it can accept the electron pairs, that's why it can act as Lewis acid. Next, molecules having multiple bonds between the dissimilar atoms. For example, you take CO2, NO2, P2O5 and P4O10, etc. act as what? Lewis acid, means this can accept the electron pairs. And molecule elements with electron sextet, means here oxygen, sulfur, they are having 6 electrons in their valence shell, they are also can act as what? Lewis acids. Okay. Next, type of Lewis bases. First, what is a Lewis base? The Lewis bases are divided into 3 types, they are given. Okay. So what is a Lewis base? Electron pair donor, electron pair donor, electron pair donor is called what? Lewis base. What is a Lewis base? Electron pair donor is called Lewis base. So there are 3 type of Lewis bases are there. All anions you take as the Lewis bases. For example, chloride ion, bromide ion, and CO3 minus 2 carbonate ion, PO4 minus 2 phosphate ion, sulfate ion, etc. All this you can take as the Lewis acids. Next, molecules with 1 or more lone pairs on the central atom. For example, NH3 you take. In NH3 we are having 1 lone pair on the central atom, and you take the PH3 also. PH3 also is having 1 lone pair, and you take H2S. Sulfur is having 2 lone pairs on the central atom. H2O you take. Oxygen here having 2 lone pairs on the central atom. So all these can act as what? Lewis bases. Molecules with double bonds. Are also C double bond CH2 double bond CH2 and CO2. CO2 also can act as what? Lewis base, right? So etc. All these are known as what? Lewis bases. Okay. So means what is the Lewis acid? Electron pair acceptor is Lewis acid. Lewis base means electron pair donor is Lewis base. Next, you will see examples for acid base reaction. So what is the acid base reaction in the Lewis acid base theory? So formation of a coordinate covalent bond. Formation of coordinate covalent bond is the neutralization in the Lewis acid base theory. Okay. Formation of coordinate covalent bond. Coordinate covalent bond. Formation of coordinate covalent bond is the what? Neutralization. So here formation of NH3 and BF3. NH3. In NH3, nitrogen is having 1 lone pair. BF3 is having vacant orbitals. So here nitrogen can donate lone pairs to the BF3. So now here it is act as Lewis base and it act as Lewis acid, electron pair donor and electron pair acceptor. It is the Lewis acid. Next, formation of hydronium ion. Formation of hydronium ion means here H2O plus H plus. So here H2O is having lone pairs. It can donate the lone pairs to here. So it produces H2O H plus. This is the formation of hydronium ion. Simply we can take it as the H3O plus. Next, formation of ammonium ion. Ammonium ion means NH4 plus. So here NH3 plus H plus. Okay, this donate the lone pair to this one electron pairs it is donating. So now here it form NH4 plus. So this is about the acid base reactions in the Lewis acid base theory. Next see some important points. All Bronsted bases are also Lewis bases. All Bronsted bases are also Lewis bases. For example, here NH3 you take. It is the Lewis base as well as Bronsted base. Okay, right? And PH3 you take. And Cl minus ion you take. So this is the Lewis base as well as Bronsted base. Next, all Lewis acids need not to be a Bronsted acids because they need not to be contain proton. For example, see here, AlCl3 is the Lewis acid. Lewis acid. So what is the Lewis acid? We know electron pair acceptor is the Lewis acid, and it is not a Bronsted acid, not a Bronsted acid. It is not a Bronsted acid. Why it is not a Bronsted acid? Because we know Bronsted acid is what? Proton donor. H plus donor is the Bronsted acid. So here there is no proton, how it can act as Bronsted acid? That's why all Lewis acids need not to be a Bronsted acids because they need not to contain proton. Likewise, okay. These are the some important points. Next, limitations of Lewis theory. What are the limitations of Lewis theory? It cannot explain the strength of acids and bases. So in the Bronsted theory we discussed that we can explain the strength of acids and bases, but Lewis theory cannot explain. Next, acids like HCl, H2SO4 react with bases such as sodium hydroxide and potassium hydroxide, but do not form coordinate covalent bond. So here what is the neutralization in Lewis theory? Formation of coordinate covalent bond is the neutralization in the Lewis theory, but here they are not at all forming any coordinate covalent bond when they react. Simply they produce salt and water. Next, generally acid base neutralization reactions are instantaneous. So neutralization reactions are instantaneous, or simply you write very fast. Very fast. But some Lewis acid base reactions are very slow. Means neutralization reaction only is a very fast reaction, but Lewis neutralization is very slow reaction. Okay, these are the limitations of Lewis theory. And next, okay, so these are the limitations of Lewis theory, and these are the acid base theories and their merits and drawbacks. So however, any merits, any drawbacks also is there. So we are going to use all these theories. Sometimes we call it is a Lewis acid, it is a Bronsted acid, and it is a Arrhenius acid. So all the theories are valid in their point of view. That's why we are going to use all the theories. Okay. So this is a basic introduction of ionic equilibrium. So in the next video, I am going to explain you about the ionization constant and dissociation. What is the dissociation? Everything. We are going to continue these lectures. Okay. Thank you for watching.